Hi, so today's video is all about the BBC microbit. That's right. There has been a lot of discussion of this on the internet. So for the uninitiated, the BBC microbit is basically a single board embed enabled device. Basically it has a microcontroller on it which you can program using either embed online compiler, which is at embed.org, or you can use Microsoft Touch Develop, as well as a number of other options. Now the fascinating thing about this is that it has been given to school children to learn how to program. So there is a language where you can drop down blocks, and basically block by block you can basically draw a flow chart, and then you can say run that flow chart. It'll simulate it online. You can even program it. To program this, you don't have to actually connect the USB cable. You can do it via the onboard Bluetooth capability. So that means you don't actually need an entire laptop to do this. You can do this via say your iPad, or maybe some Android enabled tablet. Go onto the website, say on Touch Develop, go on there, draw the diagrams, drop the blocks in there, and correspondingly just say hit program. There's the entire process is given on the website itself, and there's a lot of tutorial work on there. So the simple things, and for to enable the kids to use this one, it's very easy. There are two push buttons available, and there is an LED matrix available. You can basically display a scrolling messages, or you can display arrows and small smileys or heart shapes, basically whatever you want to do with an LED matrix. In addition to that, it has an accelerometer which allows you to measure the acceleration. We can measure the acceleration due to gravity, so you can measure if it is tilted at a particular angle. So there is a 3-axis accelerometer in there, and it has a battery connector. So what you can do is you can use a battery pack with this thing, and you can make this altogether portable. So there are examples of this where you can connect this to an iPhone, and you can use it to change the music remotely. You can even use the press buttons to change the music remotely, so on and so forth. I got my hands on this one thanks to element14.com. The GPIOs on the microbit are accessed via the edge connector on the side of the microbit board. So as you can see, there are five of those connectors that are compatible with banana cable connectors. Unfortunately, the other teeth are actually quite small. So in order to use the other pins, we have an edge connector by Kytronics, which is based out of the UK, and these guys were kind enough to send me a sample long before I actually received the BBC microbit itself. So once you plug it in to the edge connector and you solder the piece of PCB that comes along with it, you can access all of the pins. You can see in detail, and I'll actually go into the details I'll zoom into this actually later on. So you can see that all of the pins are accessible here, which includes the big banana pin cables, and there is a general purpose area with the ground and the VCC down here. What I'm going to do is I'm going to solder some Berg strip connectors here, and I'm going to use some off board connecting wires to actually connect this to something else. So what am I going to do with this? Let's see what we can do with this. Okay, I'm going to start with soldering the headers, and there's a lot of GPIOs on there. So it starts with 30. The numbering is a bit odd, but that's okay, because all I need is to be able to access these using jumper cables, or I don't know what you call them. They're called jumper cables in some places, different places, different names for these things. Just clean out the soldering. Okay, so there we go. I have a header soldered, and that gives me access to 0 volts. There's the 3 volts, and there's pin 1, 2, 3 so it's 0, 1, 2, 3 volts, and ground. So ground 3 volts. There's pin number 2, there's 1, and there's 0. So really that numbering doesn't make a lot of difference to me, but yeah, it's available. Okay, so what I want to be able to do is I want to be able to connect to the GPIOs via something like this. So say I want to connect to the ground. Now I should have some black and red color codes. FOE. Okay, so what I'm going to be doing is white for ground and choose a color. Okay, yellow for the 3 volts. Fantastic. Most weird combination ever. Okay, so I got the 3 volts and 5 volts connected there. Okay, so where are the rest of these? What am I supposed to do with the rest of these? What I'm thinking is I already have some boards. Now this is something that I did for a different project. I have an infrared LED as well as a photodiode, so I am able to detect if there is a white or black object in front of it. Basically that means is I can use it as a line follower robot. Now we're getting somewhere. I have a line following robot. I want a line following robot. I want to be able to detect a black and white line, so every time there's a black line in front of this, the output changes. And the schematic for this thing, let's check out the schematic for this thing. I'm using an operation amplifier here, but this thing is an LM324. The problem is that LM324 will not work below 3 volts, and probably when you connect a battery pack with this thing, the voltage drops and the 3 volts drops to 2.9 volts and 2.8 volts. It may work, it may not work, but what I understand is it'll drop out of spec. So I don't want to do a out of spec design. Instead, I have a simple solution. What I'm going to do is I'm going to cut this piece off, and I'm going to power this directly from 3 volts, and instead of using the comparator, I'm going to do something in software. Let's see what I can do something in how we can do something in software. Alright, so what we're trying to do is we're going to try and interface some sensors, or basically photodiode sensors, with our microbit. Before we can actually do that, let's see what the microbit can actually interface with. So go to developer.mbed.org/platforms/microbit, and there you can see the embed libraries, which are basically provided by Lancaster or Lancaster University. I don't know how to pronounce that. Those are libraries for the embed platform that allow you to use just simple functions to access the accelerometer, the compass, and all the other parts of, in fact, even the Bluetooth capabilities of the microbit. And the library or the device abstraction layer is available. If you want to modify it, you want to contribute to it, go ahead and you're most welcome. There are example programs such as the blinking LED, of course, and there are other sample codes. I've already tried the sample code. It's quite simple. It's C++ code. With all you have to do is just include the library or the DAL or the device abstraction layer, and you're good to go. But that's not part of this tutorial. What I'm going to do is I'm going to first take a look at the GPIOs available on the BBC microbit. And as you can see, the big banana cables are ground 3 volts, and there are 3 inputs, and all of these are analog in compatible. So you can see analog in, analog in, analog in. Perfect. So I am going to be accessing these analog ins. What I want to be finally doing is I want to be interfacing the microbit with 2 infrared sensors, which are basically going to be analog in, because I'm not using an external comparator. I'm going to do the comparison part in software, and I want to do the driving of the motor, and I'm going to be using one of these other pins. I'm not going to be using the SPI. You can actually access some external peripherals, or you can even, I don't know if it's the same SPI and I2C buses that are connected to the accelerometer and the compass. You can maybe even access the onboard compass as well, or the different devices. But again, that's not part of the tutorial here. What I'm going to be doing is I'm going to be using, for this video, I'm going to be just using the analog ins. That's the I'm going to be using 0 and 1 say to interface 2 photodiodes, which are going to be used with IR LEDs. And so what's going to happen is when light falls on the photodiode, the infrared light bounces off, say, a white chart paper, and it falls on my photodiode. The potential across it is going to change, and vice versa. So the schematic that I'm going to be doing, I'm going to discuss that later, but right now what I'm going to be doing is I want to write the code to read these analog pins, and I want to display it because it has this LED matrix thingy. So I want to be able to read these analog pins and maybe display it, and if I can prove that I'm reading those analog pins easily, then I can do the rest of the stuff. Okay, in order for me to write the code, there's a number of options. You can be programmed by a high-level online IDE. I can do the embed part. This I'm going to do in a later video, but simply click on this linky and oops, there we go. So you can choose JavaScript, or this is Node, basically Node.js. Block editor, a little too childish for me. I'll go with a new project with the touch develop. Now the touch develop interface is in between the coding of C++ and block diagram kind of things, so it's an intermediate kind of a place. So what I want to be able to do is I'm going to simply read one of those inputs, that's the pin 0 here, and I'm going to display it on this little display thingy. So how do I do that? I'm going to create a new variable. It's always good to create new variables. I'm going to be using 0 for, say, the right sensor, and on the right sensor I'm going to be doing a analog read. So you can do an input which is buttons, so on and so forth. I already know in order for me to read the analog pins. So for you to actually access the documentation to get to know the different functions available, you can go to microbit.co.uk/td/contents. So this is the touch develop documentation contents, wherein you can see the basics like clear screen forever, pause, etc, 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 etc. I'm the lazy man out, analog, there we go. So pins, analog read, analog, I want to be reading an analog read pin. As soon as I click on it, I can see that there's a block editor, and I do a pins analog read pin blah 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 blah. Okay, let's go back to my code. So I'm going to be doing there we go. As soon as you start writing analog, it says analog read pin. Fantastic. Analog pin P0. Let's take a look at that. Yep, it's P0. Forget that. And next thing, what I want to be doing, I want to be able to do is I want to display this. So there has to be a display. Is there a display thing? Hold on. Let's close this window. Go over there. Go back. Display. Show animation display mode. Yeah. So I should be able to say this. Nope. Hold on. More variable break bits rewind more. Is there some stuff? Image create image. No. Basic. Okay, basic show numbers. There we go. So I want to show the number which I've already read from that analog pin, right? So I want to, there we go, there's my variable, bingo. So what this is going to do, it's going to read the pin, and then it's going to display it on the the 7 segment, the matrix display part over here. I want to be able to pause it. PAU is there's basic.pause, so 100 millisecond delay. The issue here is that it will do it once and pause, and then it will be done. I want to be able to loop the loop. I want to be able to repeat it. Hold on, can I? Okay, so what I'll do here is I'll create a while. There we go, while true. Okay, so pause. Oh, and that adds a pause automatically. Cool. I don't want the pause thing. What I want to do is I want to add these 3 lines of code. So hold on a second, I'll just shift and select these 3 lines, cut selection, add code here, paste, bingo. Okay, so that means I've got to create a variable, write and read blah 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 blah. This should do it. Can I compile this? Okay, your hex is ready. So there we go. So that's downloaded. Let's switch on our little experiment. Plugged in the power. There we go. I don't know if you can see this. The pin number 0 is connected to the VCC pin right now. So what's happening is pin number 0 connected to VCC. The number that it's displaying is 1023. Hold on, 1023. That means that the ADC that is being used is a 10-bit ADC. Wow. Now if I connect this to ground, I should be able to get near 0. Oh, there we go. So it's a static number 2. That means there's a little bit of an offset if it's using an op amp or something. It's a bit of a micro amps kind of offset, but microvolts kind of an offset. But yes, it's able to read voltages between 0 volts and 3 volts. So all the way to the 0 is being read as a 2, and the 3 volts is read as a 1023, which signifies a 10-bit ADC. Cool. So that means now I can start by connecting say an external sensor. So how do I do that? Let's go. Okay, so at this point what I've already done is I've created one of the circuits that I was talking about. Unfortunately, I've tilted it the wrong way. Basically, we have a resistor and an IR, or an infrared LED, connected to the 3 volts, which is this one, and I have a photodiode which is reverse biased and connected with 2 10K resistors. That's these two and these two. Replicated this whole thing 2 times. So this is for so this is for the right sensing and the left sensing. More or less, I'm having 2 sets of sensors, and this reverse bias photodiode, when there is something reflective or white in front of it, the resistance of this thing should drop and the voltage should actually go up, and vice versa. So what I'm going to be trying to do here is I've not changed the code anyways. I've just used the edge connector. I've connected the 0, that's the blue one, to this particular one, which is the right one, and this one has been connected to the P1, which is the left connector. Of course, I'm not reading the P1 or the left sensor value right now. What I'm going to be simply doing is I'm going to be switching it on out of just without changing any part of the code. As you can see, it's scrolling 853, I think 850. So it's in the 800s line. As soon as I put a white piece of paper in front of it, you can see the voltage. Hold on a second, of this thing. Now it's dropped to 7576. So it's radically dropped all the way from, hold on, changing 72. Hold on, it dropped from 851 and 85 something all the way down to, from 851 all the way down to 98. If I even take the paper closer, so it should drop even 65. So that means the sensor is working. I don't know if I've done everything right here. Maybe I've actually reversed the location of the diode and the resistors, but more or less you get the point. I'm able to detect once there is some kind of sensor, once there is some kind of object in front of the IR photodiode. And this way I am able to detect a white and the difference between a white and a black line. So in the next part, what I'm going to be trying to do is since I'm able to read these sensors, I'm going to be trying to drive motors with this thing. So let's see how that works out. Of course, let me just correct the schematic. The schematic for this thing right now is VCC, I think. Again, 10K. I've got split units, right? 10K, and my photodiode is connected here, and this is P0 right now. The other one is going to P1. Let me just verify that right now. Let's just flip it over. So this is my sorry for the messy soldering. It was done in like 10 minutes flat. So this is the VCC line. This goes all the way up, and I'm assuming that it's going to be connecting to the 10K network. So you can see it's connecting to the 10K network over here. Yep. So this is the 10K network. So there's a VCC here, jumping all the way to the photodiode, reverse biasing it, and this terminal should be connected to ground. And this is the junction, and it shorts out to here, and this is my ground terminal. So yeah, this is the schematic. You can do it this way as well. In that case, the output of the ADC, instead of dropping, will rise once you have a white line coming in front of or a white patch coming in front of the. All right, so before we move on, I just wanted to go through a small piece of code that I've written. The first thing I've done is I've replaced the script name with line follower, because I don't want it to be wondrously awesome script. I want to be able to recognize my script. The next thing what I've done is I've replaced the lines that displayed the numbers that were read by the ADC I've replaced it with an if then else loop. So what does this if then else loop do? It basically reads the sensor values. If I understand correctly, once there is a piece of white paper in front of any of the sensors, its value will drop down all the way up to 60 or 70, basically sub 100. And if there is nothing in front of it, or maybe there's some kind of white line or black paper or black some line or something in front of it, then this value will rise all the way up for 700 or 800 or so. So I've taken the value threshold value 400, and I'm checking if both of these sensors are reading a white line, that is the reading is less than 400, then it's on a piece of white paper and it should proceed straight ahead. So it displays the arrow 400 like so. Then if I hit a black line on the left sensor, so what happens is, if on the left sensor the value goes above 400, which means that there is no reflection and from the left line, that is it has actually hit a black piece of paper or a black line on the white piece of chart paper, then I need to correct the course and I need to move more towards the left, because that indicates that I have actually veered off rightwards. So if the left sensor is reading a black line, I need to proceed towards the left, and vice versa. If I read a right sensor with the value which is I think I've flipped it here, right? Okay, so hold on. So if I read a white line and a black line, yeah, that's okay, white line and a black line. If this says a right is getting a value greater than 400, my threshold value, that means it has hit a black line. So I'll just do a basic, then plot LEDs, and I want it to turn the other direction, right? So there we go, and okay, so turning left, turning right, and if I hit a black line on both of the sensors, that means I am somewhere, either I have actually dropped off of the face of the earth, or actually the table, or in that case somebody's picked me up, or picked the line follower robot up, so I should just stop both of the motors so it displaces across. So with that done, I can do a compile, and let's see what the output looks like. Let's see how it physically reacts to input. Alright, so now I've already gone ahead and uploaded the code, and I've connected the sensors, and I've powered up the microbit. So let's see what happens. So I have a white visiting card. As soon as I put it in front of both of those photodiodes, right, they have to be really close. I don't have a very good quality of photodiodes and IR sensors, so these things are going to change with time. As soon as there is something detected on both of these sensors, you can see it says I'm going forward. So as soon as there we go. So there is a problem on the black line on the right side. So I said I need to move towards the right. No problem. Again, if I move it, there we go. So if the sensor only detects something on the right side, then it says there is a black line on the left side, and I have to move again to the left side, because I want the black line to be in the middle of both of those sensors. And if for some reasons I hit a black line on both of the sensors, and it says I am not going anywhere. So yep, that's the basic line follower routine. In the next video, what I'll be doing is I'll be connecting some DC motors. I'll be using a motor driver. I'll be explaining an L29 3D how to put one together, and then connect some DC motors to one of these microbits. So see you next time.